Now the next signal is to find the trigonometric Fourier series of the signal x of t. As I told you, you go through the steps. First is you always write that the signal satisfies the Dirichlet conditions. Okay, Dirichlet condition. So trigonometric Fourier series exists. So that is the first step. The second step, I told you to calculate the values of t0 where the signal repeats after that periodic interval of the time. So if you look at this signal, the signal repeats after this periodic interval of the time. So therefore the t0 is equal to, it is a 2 pi. And from t0 you calculate the omega 0. Omega 0 is equal to 2 pi divided by the capital T. So this is equal to 2 pi divided by 2 pi. So this is equal to 1. Third step, you write the values of the x of t in terms of mathematical equation. X of t consists from 0 to 2 pi. So x of t is equal to, its value is 1. So its value is 1 for t is greater than 0 and less, greater than or equal to 0 and less than it is pi. And this is equal to 0. It is greater than or equal to the pi and less than it is the 2 pi. So this is called as the mathematical equation. First step, it satisfies Dirichlet condition. Second, find out t0. From you calculate the omega 0. And next step is to represent this graphical representation into the mathematical equation. Fourth step, you just check the symmetry properties of the signal. The signal is even. So when x of t is equal to x of minus t, if you put the x of minus t, so if you represent x of t and the x of minus t, they are not equal. So it is not even. Even the signal is not odd signal. If signal is not even or the not odd, you have to find out all three coefficients, that is a0, an and the bn. So we will find out the first, that the coefficient, find the coefficient equal to a0. That is called as the DC value. If there is equal positive half cycle and the negative half cycle, then a0 is 0, but there is no equal and positive and the negative half cycle. So you find out a0. So therefore a0 is not equal to 0. So you write the formula for the a0. a0 is equal to 1 upon t, limit from t0 to t0 plus capital T, x of t into the dt. This is the simple formula. So the capital T is equal to the 2 pi. So you can write this equal to 1 upon 2 pi, and the limit from 0 to 2 pi, pi to 2 pi is a 0. So therefore t0 to t0 plus capital T, the signal exists from 0 to pi only. And x of t is equal to 1, so it is the dt. Integration of dt is the t. So it is 0 to pi, and 1 upon 2 pi will be as it is. So if you like 1 upon 2 pi, so upper limit pi minus lower limit, that's 0. So equal to pi, pi will get cancelled. So a0 is equal to 1 upon 2. That's it. An is equal to 2 upon t. So this formula we know. Omega 0 is equal to 1. So that already we have calculated. So if you put, so x of t is equal to 1. So it is only the cos nt dt, and limit will be from 0 to pi, because the signal exists for 0 to pi only. And capital T is a 2 pi, 1 upon 2 pi. And the integration of this cos is the sine. So sin nt, derivative of nt is only n, 0 to pi will be there. So 1 upon 2 pi n, I will take it outside. Then sin n pi minus sin 0. And we know that sin 0 and the sin n pi is equal to 0. So therefore the an coefficient will be 0. The next we will find out the bn coefficient. So to calculate the bn coefficient, the formula is there, but bn is associated with the sine term. So I will write the formula. X of t is 1, limit will be from 0 to pi. So 2 will get cancelled. So it is equal to 1 upon pi, and the integration of the sine is a minus cos. So minus cos nt divided by derivative of this is 1, limit will be from 0 to pi. So n, I will take it outside, it will be 1 upon n pi. Then upper limit minus cos n pi minus lower limit minus will become plus the cos 0. And we know that the cos 0 is 1 and cos n pi is minus 1 raised to n. I will substitute the values 1 upon n pi minus, as it is, minus 1 raised to n plus 1. I will take minus outside. So the minus 1 upon n pi, it will become minus 1 raised to n, and this will become minus 1. And if you look at the values of the n when it is equal to even and when it is equal to odd, when n is equal to even, like the n is equal to 2, minus 1 raised to 2, it will become 1, 1 minus 1, 0. Similarly, if you take 2 is n is equal to 4, 6, 8, so the value of bn equal to 0. And when n is equal to odd, that minus 1 raised to 1, so that is a minus 1, it will become minus 2, and this minus will become plus. So therefore it is the 2 will be there in the numerator, and in the denominator n pi will be there. So the values of the bn is equal to 0 for n is even, and it is equal to 2 upon n pi when n is equal to odd. So our problem is over. Now you have to write the trigonometric Fourier series equation. So I will write, so a0 we have calculated equal to 1 by 2, an is 0, bn is equal to 2 upon n pi, n is equal to odd. So as an is 0, so your trigonometric Fourier series will consist of a0 plus n is equal to 1 to infinity, bn sin nt, and for the n is equal to odd. So just you substitute the values. So this is x of t is equal to 1 upon 2 plus, and it exists only for the n is equal to odd, that is 2 upon n pi. So you can write summation n is equal to 1 to infinity 2 upon n pi and sine that nt. So this you can write, so x of t is equal to 1 upon 2, and here you write for n is equal to the odd, n is equal to 1. If you take n is equal to 1, so it is the 2 I will take it outside, okay, 2 upon the pi I will take it 2 upon pi outside, n is equal to 1, 1 upon n, that is 1, the sin nt is a sin t, plus n is equal to 3, 1 upon 3 sin 3t, plus 1 upon 5 sin 5t, plus so on. So in general you can write x of t is equal to 1 upon 2 plus 2 upon pi in bracket, that is sin t, plus 1 upon 3 sin 3t, plus 1 upon 5 sin 5t, plus like this. So this particular equation is called as the trigonometric Fourier series equation. Okay, so it means this any signal graphically which is represented in the time domain, that can be reconstructed with the help of only sine and the cos term, which is called as the trigonometric Fourier series.